Hey guys, so we're continuing on with ellipses today. But before we do that, I was going to just do a review question from the, there we go, sorry. I'm going to do a review question from the parabola chapter here. Okay, so let's see how we do on that. Turn that off. Okay, so let's say we have a parabola that has a vertex at 3, -5. Okay, and you're told you have a directrix at, let's say, x equals, let's say 1. No, I should say, let's say 6. X equals 6 here. Okay, and you're asked to write the equation of the parabola. Okay, so I think the first thing we'd want to decide is, how does this thing open? Is it one that's opening horizontally, or is it one that's opening vertically? And so you can kind of tell just by the equation that the fact that the directrix is x equals 6, that is going to be a vertical line. And so the directrix is always perpendicular to the axis of symmetry. So the axis of symmetry would be a horizontal line. So I kind of know it opens left or right, but maybe that's a bit tricky. So let's just do a little sketch of this thing here. So I'm going to do a real rough graph here. And so I know I go over 1, 2, 3, 1, 2, 3, 4, 5, and that's where the vertex is. Okay, and then the directrix is at x equals 6. So there's 6. So if I was to draw the line x equals 6, that's supposed to be the directrix. So I know that a parabola has sort of its, I guess, its pointy end always facing the directrix. So I know that the graph has to open something like that. And so now I know the axis of symmetry would lie along this line. So the axis of symmetry is actually y equals -5. And the directrix is x equals 6. So this is the axis of symmetry. And now I guess, what do we know? Well, we know that we're working with a very special equation, which will be 4p. And now in the brackets, just a reminder here, you always have a square term on the right-hand side if you use that one. And now you have to realize which term would be being squared here, I guess. So since it's not opening up and down, that's normally x squared, it must be the y's that are being squared here. And so I'm going to go x minus h minus k here. So you always kind of need to get your variables h, k, and p. And sometimes you can just find them right from the information in the question, and sometimes you have to do a little bit of algebra to figure out what those numbers would be here. So let's figure out the h and k, because they already told us the vertex. That's almost like a give me. So you know your h value is 3, and you know your k value is -5. So now you got to figure out this p value here. So how can we do that? Well, p is the distance from the focus to the directrix, but sorry, I say again, it's the distance from the focus to the vertex, or it's the distance from the vertex to the directrix. So we know that the distance from here to here, that should be p. So notice we're at 3 for the vertex and 6 for the directrix. So that's a distance of 3. So I know the p-value is 3, except notice how it's opening. It's opening to the left. So the p-value will be -3 here. So when I plug that in, I get -12. X minus 3, because that's the h value, equals y minus -5, which is really y plus 5, all squared. Okay. Now, if they'd asked for the focus, that wasn't actually something I asked for here, but let's just sort of show you how you would determine that. So the focus has to always be on the axis of symmetry, but it has to be kind of inside the mouth, if you think of it that way, the curvature part of the parabola. So notice that the p-value is 3. That's from the vertex to the directrix. That's this distance here. And now if you go from the vertex along the x-axis, 1, 2, 3, you should find your focus then. So that would be at an x value of 0 and a y value of -5 then. Okay, so I just wanted to show you a question like that where you're given some information, you have to write the equation, and then we're just going to launch into ellipses today. Now, once again, just like the parabola, I'm not going to define the general, so the standard equation for you, but the book does do a fairly good job of explaining that. But I'm not going to test you on like how we actually get the ellipse formula here. Okay, so there are a few things about ellipses, a lot of sort of terminology we have to be familiar with here. And the ellipse can run sort of one of two main ways. But here's how the formula is written here. So it's x squared, or sorry, x minus h all squared plus y minus k all squared. So you can see that h and k being used again. And that's going to always equal 1 for the ellipses. And then we have them all over two other letters now. So it kind of looks like a circle, really, a circle equation. But we're going to divide one of the sides by what we're going to a squared, and the other one we're going to call b squared. We're going to define all these things for you. But once again, you have h, k, and now instead of p, like in the parabola, you have a and b. So let's sort of make sense of that then. So I'm going to draw an ellipse. I think I can do that with this thing here. And I'm going to draw an ellipse that would kind of fit this definition. Whoa. That's a kind of a strange looking shape. There we go. There's my ellipse. Okay, so if the graph is longer in the x direction, so running from, let's see here, so the x direction, we call the long axis from the end of one side to the other, so the sort of the longest diameter, if you want to think of it that way, that's going to be our a distance. And then if we look at the longest distance in the perpendicular direction, that's going to be our b distance. So I'm just going to draw these in first before I put letters on here. So hopefully I've kind of got the center approximately. Ooh, that was the wrong button. There we go. Okay, so the center, I'm going to put a blue dot here. Blue dot is the center of the ellipse here. And so this purple axis here, this is what we refer to as the major axes. It's the longest axes. And then this axis here, we refer to as the minor, probably should use green here. Sort of color coded it for a reason. So the minor axes. So the minor axis here is actually vertical, and the major axis is horizontal. And if the ellipse is longer in the x direction, then we'll always have the a term underneath the x term. And the reason for that is that from the center to the end of the ellipse, so the end of the ellipse, this is the distance a. And so over here is the distance a. So from the center to the end of the ellipse on the long direction is a, and from the center to the other side is also a. So the major axis always equals 2a. I guess I should have an I there, axes. And the minor axes, this distance is b, and this distance is b. And so the minor axis is always equal to 2b. Now, there are ellipses that open the other way, and I'll talk about those in a second, but I'm going to write a different formula for that. So before I do that, the vertex here, I should say the center, sorry, is just like the circle. So the center has the coordinates h, comma, k. So that's where the center is. What else do we need to know? So center is that way. Oh yes, and then from the somewhere around here and about over here, we actually have what we saw in the parabola. So inside the parabola, there was this thing called the focus, and an ellipse also has a focus. And in fact, it has two focuses. So we don't say focuses, we say foci, which sounds funny, actually. Sounds like I'm angry with you. But so the foci are the 2 points on the major axis, always on the major axis, never on the minor, that are centered just on equal distance from the center. And that distance is C. So this distance here is C, and this distance here is C. And so the distance across from both foci is actually equal to 2C. Okay, so let's do one more thing here. Yeah, that's pretty good, actually. So let's do a question maybe that has all this information in here. So let's say you have a major axis. So you have an ellipse. That has a major axis equal to 20 and a minor axis equal to 12 and a center at 3, 4. And let's say you're also told that the ellipse, the major axis, is parallel to the x-axis. Okay, so if that's true, then once again, you could just do a rough sketch. You don't have to draw this super nice. It's really rough and ready kind of sketch here. So what do I know? Well, I know the center is 1, 2, 3, 1, 2, 3, 4. Okay, and I know that since it's the since the major axis is parallel to the x-axis, to the x-axis, then it would have to be longer that way than it is this way. So why is that important? Well, if that's true, then I have to use the formula above because the a term is underneath the x value. Okay, so let's try that. So let's go x minus h all squared all over a squared plus y minus k all squared all over b squared equals 1. Now, for this question, you need 4 bits of information to complete the equation. So one is you need your h value, you need your k value, you need your a value, and you need your b value. Okay, so the h value has to be 3, because that's the center part for the x, and the k value has to be 4. So I already know 2 numbers right away. Now the major axis was 2a, so 2a equals 20. So a would equal 10. And of course, 2b is the minor axis, and that equals 12. So b is equal to 6. So that's fairly easy, actually. So let's plug the numbers in. So that's going to be x minus 3 squared all over a squared, which would be 100, plus y minus k, so that's going to be 4 squared all over b squared, which is 36, equals 1. Okay, so that's the equation of the ellipse here. So let's just keep working with this question, and let's say where are the foci? So where are the foci? Well, the foci always have to be on the major axes. So they have to be somewhere here and somewhere over here. So if we drew this ellipse, we could say, well, the minor axis is 12, we said. So that's going to be, let's just use orange, yeah. So I'm going to go 1, 1, 2, 3, 4, 5, 6. So up there, and then 1, 2, 3, 4, 5, 6 down here. And then I have to go 10 out either way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to kind of look like that, approximately. Okay, and so the longer axis is definitely along the x-axis here. So there's got to be a foci over here and a foci over there. I'm just not sure where exactly they would be here, but I know the distance is supposed to be c from the center, and so since I know the center is 3, 4, I just got to count whatever c is here. So let's go back to the picture up here. So we said the major axis is 2a, but it's a from the center to one end, and of course it's c from the center to the foci. So how do we find that that c value then? How do we actually jump to doing that? So we're going to take a look at, now where did I put that? Yeah, there we go. Okay, so now this formula, once again, is in the book, and I'm not going to derive it for you, but you can actually pretty easily see it from the picture. And that is that the A's, the B's, and the C's are all related to each other by a formula that is actually very close to the Pythagorean formula, but the order is different. So the order actually for this is that a squared, the major axis squared, is equal to the minor axis squared plus the c squared value. That is the distance, the distance from the center to the foci. So let's see if we got some numbers for this. So we know that the a squared value is 100, right? That's a was 10, so that's 100. And the b squared value was 36. You can kind of see that here and here. And that's going to be equal or plus c squared. So if I isolate for c squared, I would have 100 minus 36, which is 64. And then I square root both sides and I get 8 then. So the distance from the center to the foci is 8 units. So this would be 8 units, and that would be 8 units. Now notice you're starting at 3 here. So one of the foci, it's called F1, it's going to be 8 units over from 3, so that'd be 11, but it'd be the same height as the center, which is 4. And then foci number 2 would be 8 units the other way, so that would be 3 minus 8, which is -5, comma 4 units that way. Or sorry, 4 that way. Okay, so I'm just going to highlight this here because it's easy to forget that. So what I would say is maybe write that down somewhere in your notes. And once again, you can use your notes for your test. But you want to remember that that's the formula. It's not a squared plus b squared equals c squared. We'll just stop there with that one, okay? So let's try another ellipse here. So let's take an ellipse that actually looks this way. Okay, so it's longer in the y direction. And so what I'm going to do here is be a little bit quicker here with this and just draw a line down the middle as best I can. And so now that's going to be the major axis, longer that way. Okay, and then the minor axis will be the distance across the middle here. So minor. What's still true is that this is still b, that's still b, and this is still a, and that's still a, and of course they should meet at the center. So that'd be the center of the graph right there. So what's the formula here? Well, it's still x plus k, sorry, x minus h all squared plus y minus k all squared, and still equaling 1. But the difference now is that the a squared value is actually going to be underneath the y term. And that's because, the major axis is longer in the y direction. And then the b squared value will come underneath, the smaller number would come underneath the x term here. And so just like above here, where is it here? you've got information like center and foci and major axis. So the center here is still going to be h comma k. So that seems to be like a common theme now. We've seen that quite a few times. In circles, it was h comma k. And in ellipses, it's h comma k. Now in parabolas, we actually used h comma k for the vertex, but you can see there's obviously a relationship here with that. So let's take a look at this ellipse here. Let's say ellipse. Let's say you have x squared. Actually, let's go x minus 3 squared plus y minus 2 squared equals 1. And then let's make this make this 25, and let's make this 16. Okay, and we're going to ask you a few things. Let's say, where are the foci? Where are the foci for this question? So I think what we're going to want to do is get a sense of how is this thing longer, because you need to know, are you using this formula, okay, or are you going to be using this formula over here? So you have to get a sense of which way it's longer here, okay? Now, once again, some of you just be able to look at that and know, but I'm going to do a quick little sketch here. So I'm going to say that this thing would have to have a center at 3 comma 2. 3 comma 2 would be the center. So 1, 2, 3, 1, 2. Okay, so 3 comma 2. And then I know the a squared value is the bigger number, and that's 25. And I know the b squared number has to be the smaller number, which is 16. So really, in this case, a is 5, and b is 4, which means the major axis is 10. And the minor axes would be equal to 8. Okay? Now, which way is it longer? This is where you got to be careful here, is that the a squared value is underneath the y. So the largest value is underneath the y. So it must be longer in the y direction. So I'm going to go from 2 and I have to go up 5. 1, 2, 3, 4, 5. So I'll put a little dot there. Go down 5. 1, 2, 3, 4, 5. Put a dot there. And now I have to go left and right 4 units because the b value is 4. So 1, 2, 3, 4. Little dot there. And 1, 2, 3, 4. Put a dot there. And so if I draw this, I get this kind of, it's not a great shape because I'm kind of drawing pretty quickly here. Okay, so which formula am I working with here? Well, I'm working with the y squared formula here. So the foci have to be along the major axis. And of course, it's longer in the y direction. So I have to have a foci up here and a foci somewhere down there. So what would be true is the coordinates of these foci would have to be 3 comma something, because notice that they are the same x value as the center of the shape. So how do I find c again? Well, I know that a squared is equal to b squared plus c squared. So c squared would equal a squared minus b squared. So I have a squared value of 25, and I'm minusing 16. So my c squared value equals 9. So my c value equals 3. So basically, I have to go up 3 and down 3 from the center to find the foci. So I go 1, 2, 3. So that's pretty close. And that would be 3 comma 1, 2, 3, 4. Sorry, that's 1, 2, 3, 4, 5. So 5. Okay. And then I go down 3. So that would be 1, 2, 3. So about there. So that would be 3 comma negative 1 then. Okay, so that's kind of tricky there. That's kind of tricky. What else can I show you guys? Let's see here. Let me pick a question. It's kind of, oh yeah, let's do one of those. Okay, so let's take a look at this picture here. Let's take a look at this equation. So we have 16 x squared plus 4y squared plus 96x minus 8y plus 84. And let's say the question here is something like find the center of this thing. Or find the focus, maybe. Actually, let's make it even easier than that. Focuses can be kind of hard sometimes. Let's find the major axes, how long the major axis is. Okay, and yeah, I think that's pretty good. Okay, so once again, just like the questions we've seen before, it's really hard to tell that from this. It's not very clear what you would do with this thing. So we're in general form now. We're going to have to go to standard form. So we're going to have to complete the square on this bad boy. So what I'm going to do is arrange my x terms together first. So I'm going to go 16x squared. Playing poker tonight. All right. 16x squared plus 96x. And then plus 4y squared plus or minus 8y, and then equals negative 84 here. Okay. So now what I'm going to do is I need to complete the square, but these coefficients are a bit of a problem. So I'm going to factor these numbers out. Now this is tricky here. So I'm going to get you guys to, you might need to rewind this again just to see what we're doing here. I'm going to change this to blue. Blue is a good color. There we go. Okay, so I'm going to factor out a 16 here. So 16 bracket x squared. Now what is 96 divided by 16? 96 divided by 16 is 6. So it's going to be plus 6x plus a number. Close the bracket, factor out the 4. And you get y squared minus 2y. And you're going to go plus a number equals, I'm going to scroll this way so you can see this properly, negative 84 plus a number, and then plus the other number. Okay, so you're actually adding two different numbers here. Okay, so let's complete the square on the first set of brackets. So 6 divided by 3, sorry, 6 divided by 2 is 3, squared is 9. And then 2 divided by 2 is 1, squared is 1. Now don't put 9 and 1 here, because notice that these numbers are being multiplied by the coefficient in front of those brackets. So I need to be careful here, okay? So this 9 you see here, this 9, that 9 there is being multiplied by the 16. So 16 times 9 is 144. So I have to add 144 on this side. And of course, this 1 we see here, this 1, it's being multiplied by the 4. So I actually added 4 to that side. So I'm going to have to add 4 on this side. Okay, so now what we do is we look at our 16x plus 3 all squared plus 4 times y minus 1 all squared equals, and now I go 144 plus 4 minus 84, and I get 64. Okay, so we're getting somewhere here. And now what I want to do is I want to divide both sides by 64 because I really want that side to be a 1 here. So I have 16 divided by 64, which is 4. So I get x plus 3 squared all over 4 plus 4 divided by 16, or sorry, 4 divided by 64, which is 16, giving me y minus 1 all squared equaling 1. So I divided everything by 64 there, okay? So what do I know? Well, I know my h value is negative 3, and I know my k value is 1, so the vertex must be negative 3 and 1. Was that one of the questions we were asked? No, we were not asked that, okay? We're asked about the center. That's even easier. So the center here must be, oh, did I say that right? We are doing center, sorry. So the center here must be at negative 3, comma 1. And major axis is easy. So the major axis is the longer axis. So it has to do something with the 16. So I know that a squared would equal 16. So a would equal 4, which means the major axis, which is 2a, would equal 8. So 2 times 4 is 8. And that's all they wanted there. Yes. Let me just double check that. Okay, so I'm going to stop there. I think that's a good start, and we'll give you some questions on that.